All right, I think we'll get started. So good morning, everyone. Thanks for coming so early in the morning. I know being in Vegas, it's really hard not to stay late at night. And I sure did have to resist my temptation of not going drinking yesterday, just to be on the session today on time. But I'm pretty sure that tonight is going to be pretty good after my session. A lot of drinking, but let's get started. So I'm Vinay Balasubramaniam. I'm part of the SQL Server team, and I'm responsible for all System Center integration work for SQL Server, including SQL Azure. With me is my esteemed colleague, Roman Yusuf. He's from ViaCode Consulting, and they do a lot of our development work for SQL Management Pack. And we have some members from the development team as well in the audience. So it's going to be good. So first of all, thank you for all your feedback and support you've given us for SQL Management Pack, SQL Server and System Center 2012. We have tried to incorporate most of the feedback in the current release of SQL Management Pack. We sure did miss few of the important features, but we're committed to making sure that in the subsequent releases we add all those good capabilities. So today is going to be very exciting because we're going to show you a lot of capabilities we've added for SQL 2012 Management Pack, a lot of demos, and we'll also cover what's coming in the SQL Azure Management Pack as well. So agenda is straightforward. I'm going to talk about the new features of SQL 2012. Then I'm going to hand it off to Roman, who's going to walk through some of the critical features of SQL Management Pack, especially around mirroring, space monitoring, and blocking sessions. Then I'll come back again and talk about how we talk about the SQL Azure Management Pack to light up some hybrid monitoring scenarios. So key takeaways. Enterprises, IT operators in enterprises have this challenge of making sure that their data centers are up and running 24/7. And data tier is one such critical component which they need to make sure that it's highly available and fault tolerant. SQL 2012 is, in a lot of ways, is a game-changing release because we've added a lot of capabilities to really make your data tier application highly available and really reduce your downtime, which you both planned and unplanned downtime which you have for your data tier application. And one of the capabilities in SQL 2012 is the always-on capabilities, which is really going to bring you peace of mind in terms of making sure your data tier applications are up and running 24/7. We understand that your journey to the cloud adoption is going to be a slow process, and we want to make sure that we add all the tools and capabilities that you're already familiar with to make this migration to the cloud computing world seamless and easy. And we're going to show you how we have added those capabilities in the SQL Azure Management Pack to really light up the hybrid experience much more seamless and much more easier way. And again, thanks again, keep your feedback and inputs coming because we really value that. So as key takeaways, we're going to talk about how SQL Server is really going to be so critical for your mission critical applications with always-on capabilities. We're going to talk about how we have made sure that there's extensibility built into the management pack to make sure that you can easily extend your health model within SQL Server, and of course, the ramp up to the cloud. So quick poll, what is your current HADR story in your enterprise? How many of you use DB mirroring for your HADR? All right. What about replication? Lock shipping? All right. As I said, a lot of people use a different combination of all of these high availability capabilities. But really with always on, our main goal was to unify a lot of these capabilities so that we get best of the Windows failover clustering, database mirroring, and lock shipping into one clear solution so that we don't have to mix and match these different solutions. You really have one always-on feature which you could use for your HADR capabilities. And how many of you use SQL Management Pack today? And all right, pretty good. So that's good. So before I go into the capabilities of SQL Management Pack, let me give you a quick 101 on always on. So as I said, always on combines the best of Windows failover clustering, database mirroring, and lock shipping. There are three key concepts in always on. There's availability group, which is availability group supports failover of discrete units of user database as one unit. These discrete units of database are called availability databases or database replicas. The second concept is availability replicas. So these availability databases are really hosted in a container, a logical container called availability replicas. There are two kinds of replicas, the primary and secondary. So primary replica makes the database in a read-write mode. And primary uses transaction logs to synchronize this data with secondaries. And you can have up to 4 secondaries, unlike mirroring, where you can only have 1 primary and 1 secondary. With always on, you can have 1 primary and up to 4 secondaries for your failover. These replicas use data synchronization to move their transaction log from primaries to secondaries. And the secondary replicas use these transaction logs to apply that transaction log on the databases. So this is very useful because now you can suspend the data for the secondary replica without affecting the databases in the other containers, which is very different from database mirroring. The second useful thing which is different from mirroring is your secondaries, instead of sitting idle, can be used to run read-only workloads. And that really gives you high level of scalability, which you couldn't get in database mirroring. And lastly, secondaries can also be used for backup and restore of your database as well. So those are the key differences from database mirroring. The synchronization between primary and secondary can be both asynchronous for high security and reliability, synchronous and asynchronous for high availability. Or you can mix and match a combination of these two depending on your situation. So with that background, let's see what we have in SQL Management Pack. So SQL Management Pack supports discovery of availability groups, availability replicas, and availability databases. In your enterprise, you can have multiple always-on deployed. The SQL Server Management Studio tool allows you to look at one availability group connected to one instance. But with SQL Management Pack, you can actually look at all the availability groups, replicas, which are there in your environment. And we also support roll-up of health from availability databases to the availability replicas. So let me switch over to my demo machine just to give you a quick overview of how that happens. So once you import the SQL Management Pack, you'll see a new node called Always On High Availability. And you'll see 3 views, the groups, the replicas, which are part of those availability groups, and database replicas, which are your contained databases, which are part of these replicas. If I switch over to the SSMS, you'll see a similar view called availability groups, where you see the group, the primary, and what the replicas which make up which are part of those groups, and each of the availability databases which are part of that. So with SQL Management Studio, you have this dashboard view, which actually shows you a high-level health of each of those availability groups. If I click on each of the availability group, it's going to expand to show me the health of all the replicas and all the availability databases which are part of that replica. The one key difference in the always-on health model is we've used policy-based management feature in SQL Server to represent the health of the always-on databases. So if you go and expand the Management Studio, these are all the different system policies which make up the health of availability replicas, database replicas, and availability databases. The SQL Management Pack has a similar view because behind the scene, it's executing the same system policies which SQL Server Management Studio uses. So that way, we exactly have the same health which you see in SQL Server Management Studio, just that you can actually look at the health across all the different availability groups in your enterprise. So let me simulate a scenario where I'm going to suspend a data movement between the primary and secondary. So so essentially what I'm doing is I'm disconnecting the data movement from primary to secondary, and that should be a critical alert for the availability group because now the transaction logs are not getting shipped, and that IT operators needs to know that because they can engage database administrator to go and fix some of these issues. So let me go and do that. Yep. So now if we go back and refresh this dashboard, you saw most of the state has become a warning state. Now if we go back to SCORM and give it a couple of, yeah, you can, so right away the SCORM was able to detect that there was an issue with the data movement. It is able to say that particular health of the availability replica is in warning state. The availability group should also change at some point. So while we're waiting for that change to happen, let me talk about some of the perf counters which are part of the SQL management pack, which highlight the important KPIs for always on. So we have two performance views. One is the availability replica view, which has a whole bunch of performance counters, which really look at all the data movement which happens between the primary and secondary. So we have number of bytes which are being sent from replicas, the number of bytes received from the replica, and also we have the database replica view. And there are 4 key perf counters which I want to highlight in this view. So these are the 4 key perf counters which are very useful for the IT operator. One is the log send queue. Now log send queue is whenever this log send queue grows, that means there are synchronization delays which are happening between the primary and secondary. So this is an important counter to watch out as the data moves between the primary and secondary. The second one is the redo bytes. So when the redo bytes get skewed over a period of time, that means the secondary is unable to process the requests which are coming from the primary. And we need to watch out for this particular counter as well. The next one is the transaction relay. So if this goes up on the primary, there are delays which are happening between synchronization between primary and secondary, and that is something which you want to get alerted when it hits at a certain threshold. And lastly, the mirror transaction writes, which are the writes which are happening from your primary to the secondary database. So these are the 4 perf counters which I want to highlight. And as you can see that over in the last half an hour, we've been running some data on the primary and secondary, and you can see these counters which are growing and delay. And this is how it should really be. It should grow for a certain time, and it should come back. If it keeps growing, then you really have some issues going on with your synchronization which you want to get alerted on. So if I uncheck this, you can also see that the transaction delay went up and it became almost 0 until the second set of tests. We ran the second set of load on the primary and secondary databases. So let's go back to the groups. So now you saw that the particular availability group is in warning state. And if you expand that, it will tell you exactly which policy caused the warning state to happen. So in this case, the warning state occurred because the data synchronization between the primary and secondary was suspended. And with each of these states, you have detailed knowledge explaining what caused that state to occur, and you also have the history of when the state change occurred. So you see that it happened right now. And really, the Health Explorer view exactly maps to the policies view which you saw in SQL Server Management Studio, because behind the scene, the health rollup is really executing the policies, system policies behind the scene. So moving along. So again, getting alerted whenever the state goes critical, especially for enterprises, tier 1 application is critical, and we support that with always-on SQL Management Pack and always-on support. The next one is one of my favorite features, is the extensibility model for always-on health. So I want to illustrate that with a story which you see today in your enterprises. So the story goes like this. There are 2 characters, Patrick and Ashley. So Patrick is our IT operator. Patrick is our production DBA who's supporting some critical applications running on always on. And Ashley is our SCORM operator persona who's using SQL's the System Center to monitor the health of your databases. So Patrick wants to extend based on certain SLAs of his application. He wants to customize the health of his application based on some policies. So in this case, he wants to make sure that he wants to extend the estimated failover recovery time between primary and secondary because his application in his enterprise requires that the delay between primary and secondary synchronization to be very low. And Ashley, on the other hand, doesn't really understand what Patrick really wants to do, right? Because she doesn't speak the same language which Patrick has. She understands SCOM, she understands management pack, but Patrick is all about policies, T-SQL and all those different languages which is very familiar with. So essentially there is a gap in which these two personas communicate within the enterprises today. Because Patrick is all about, wants to customize his health model, but he needs to work with Ashley to make those changes in the management pack so that that same health information gets reflected in SCOM console. So how do you really bridge this gap, right? How do you make it easy so Patrick can use the tools he wants to use today and Ashley can still continue using the tools such as System Center, but they're still able to communicate. So to bridge this gap, we have added this feature in SQL Management Pack, which is essentially like this. So as I said, we are using policy-based management to execute the policy of the health. And let's take an example where Patrick wants to customize one of the policies. So behind the scene, these policies gets discovered and gets rolled up into the health of always on. And Patrick, let's say, wants to extend the health, let's say in this case, the always on extended estimated recovery time. So he goes ahead and creates a custom policy in SQL Server Management Studio using policy-based management. And automatically, the SQL Management Pack detects that policy and converts that policy into a monitor and rolls up the health of that of the execution of the policy into SCOM. So without any code, Patrick is able to explain what he wants to do in the health model, and Ashley automatically sees that in the tool which they use, which is System Center. So that is really powerful because now Patrick can go and keep extending that, customizing the policy based on his application needs, and really Ashley can continue to use the same tools, but get the same consistent view because behind the scene, they're executing the same policy which is being used in SQL Server Management Studio. So we think this is a powerful way of extending the health model without having to do any custom coding. So let me go ahead and show you a demo of how that works. So if you go to SQL Server Management Studio, you see this view called Policy Management. That's where all the policies are. And as I told a couple of minutes ago, Always On uses a bunch of system policies which are predefined. But you could create custom policies. So we have already created a custom policy, which I'll import here. So I check on that. So before that, let me get the system back into a healthy state. So once I import the policy, and especially for always on, the policy has to be imported on primary and all the secondaries. So that's an important thing to note. But once the policy gets imported, within about a minute or so, that policy will get detected in SCOM, and the SCOM monitor is going to execute the same policy to detect the health. So let's look at what the policy is. So in this case, I have a simple policy called database replica check name policy. So essentially, this policy says that if the availability database name is MMS, right, then this is healthy, right? And if it's not MMS, then it's not healthy. So whenever the policy gets executed, it'll evaluate this condition, and it'll tell you whether it's warning or critical. And the way you control the state is you can go to the description, and you can define what you want this state to reflect as. So if you say the state is going to be availability database warning, that means whenever this policy fails, it's going to show up as a warning alert in SCOM under availability database health rollup. But you can pick whatever you want, and that's how it's going to get communicated to SCOM. And you can also create a new condition. The only criteria is the condition should have a string called error or warning, because that's how we detect how it has to get rolled up into the health model. You could also add You could also add description here, and that description gets shown in SCOM. So that way you can actually, the database administration can give custom instruction on how the IT operator has to, what he has to do, he or she has to do when they see this policy fail. So that way they're able to communicate through the SCOM, through this description information here. So that's also another useful thing to remember. So let's go back to SCOM and see what has happened. So let's go. So let's make sure the policy gets discovered. So you can see that the policy is the same policy which I imported, not this one. Yep, so it's got discovered. So if we go back to the discovered inventory, so once this gets discovered, there's a node under the health model called the availability replica extended health. You'll see the same policy getting the same name of the policy which you got, which was imported, show up here. And once the policy gets executed, that state of that gets reflected here. So we're waiting for the policy to get discovered. Let's give it about a few seconds. Let's see if I made any mistake. Yeah, it's taking some time to discover. But yeah, essentially, once it gets discovered, you should see the external health here. And the way the DBS could actually schedule the policy execution. So they could go to the properties, and they could define how you want to evaluate the policy, whether it has to be done on demand or it can be done at schedule, right? So you can control the execution of when the policy gets executed. And the SCOM monitor is going to look at that periodically and see what was the last state change, and it's going to reflect the health state change there. So while we wait for the policy to get discovered, we go ahead and go to the next part of the feature set. So I told you we extended this policy health model for always on. We also added the feature for databases. So you can use the custom policy mechanism not only for always on health model, but also on a database. So you could create a custom policy on a database, and that also gets discovered in the database health model for you. So that's another thing we have done. So at least let's see if that part of the demo works. So I go ahead and I think that part of the demo works. So if we see this is another policy called SQL DB name check policy, which is essentially saying check for every database name beginning with MMS. And if I go back to my SCOM console and go to the discovered inventory, you can see that particular policy name has got discovered. And if I go to databases, take any of the database state, if I go to availability group, it's not getting discovered. So, but okay, let's move ahead. So let's go to the next one. So with that, let me hand over to Roman, who's going to give us an overview of all the other features we have added on top of Always On in the SQL Management Pack. And once we come back, I'll try to fix the issue we ran with the policies to see to make sure that it works before we end the session. So with that, I'll hand it off to Roman.
Yeah. Hello, everybody. And so, you know, I'm a very happy person, and I have two good reasons to be happy today. The first reason, because I'm here and I can talk to you about the most popular management pack, SQL management pack around the world. It's just pure statistics from the Microsoft download. But at the same time, I have second very good reason to be happy, and it's personal. Because last Sunday, I had a wedding, and right now I'm married. I'm married again. And thank you so much. And for example, right now my beloved wife, Katerina, can also enjoy this session with you. So I can introduce you my wife. OK. And so right now, let's go to demo. And I want to tell you about two most interesting features since we have in our SQL Server Management Pack since 2008 version. These features is done exactly by your feedback, by our users' feedback. And I believe that with these two features, your experience with the SQL Server monitoring become really more efficient, really more interesting, and I hope that really more nice like these two kittens. And I want to start from the first most exciting features of the SQL Server Management Pack. It's a space monitoring. You know, unfortunately, lack of free space, yes, it's like a silly, but it remains very popular case while we have database failures. And that's why SQL Management Pack as a monitoring solution for SQL Server has to provide the super efficient way to detect and to monitor this case. And I want to talk about it slightly in details. Right now, in the SQL Server Management Pack, we allow you to have any structure of your database. It could be any file groups with files allocated at any storages. So it all supported by our monitors, by our discovery, etc. And which is also very important. How many people here use autogrow settings for the databases? Yeah, some of you. Yeah, you know that if you use autogrow, you may have some performance degradation in the moment of autogrow. That's why I suppose others don't use it. But at the same time, if you have it, if you have no autogrow, and if you have it configured with some complex scenario with, for example, some percentage increase and some other stuff, it's all very important when we talk about the space monitoring, because in this case, also remaining space of the hard drive also must be it's a thing which we should keep in mind when we try to detect the free space at the database. And but it all was about like improvements, yeah. In the lastly released the SQL Management Pack version, we also introduced some new features. Right now, we allow you to allocate the database files not only on a server file system, but also on mounted volumes, which you may connect to your server via the mounted points. How many of you use mount points and allocate the database files there? It should be very popular because it's very strange to allocate it on direct attached storage. Yep. And right now, when we discover this file, when we monitor it from the space perspective, we also support this scenario, and I hope that it's great. before we have live demo, before we have some fun with failure simulation and then with trying to restore it, I want to remind you about the physical structure of the database. At the top level, we have the database, then we have file groups, and each object of the database could be allocated only in one file group, for example, table or something else. And each file group consists of several files, and data in one file group distributed across all files in the file group. And here are the two very important things here. First, the health rollup in health model of the management pack from files to file groups work as a best of algorithm. It means that we should have all files in the file group in trouble to have file group also in trouble. Yeah? And we have rollup from file group to database as a worst of algorithm. Because if we have at least one file group lack of free space, it means that we can't write any data in table allocated in this file group. It's just a reminder. And right now, I'm going to have some demo. OK. Let's go to SCOM. And if we talk about the database, so let's go to database state view. And let's find here our database, which I prepared for you for this demo. So I called it mount point database. And right now, I'm going to explain you why I choose such name. Let's open the diagram view. And OK. We have here two file groups. You can see it's a primary and secondary file group. And we have two files in each file group. It's very similar to structure which I just shown at slide for you. And so you can see that some files here is already in not healthy state, but at the same time, database is healthy because we should have all files in file group in trouble to have a real issue with our database. And another important thing which I want to note here, that file 4, which we have here, it's allocated at mounted point. Let's go. And you can see that it's allocated at C mount point, blah, blah, blah. And let's check. Maybe I'm trying to deceive you, and it's not there. Let's go to the SQL server and check where this. Yeah, so we can see that mount point folder is a real mount point. And it has some free space there, about 76 megabytes. Let's go back to SCOM. Oops. OK. And another important thing, that only file 4 has auto-growth settings enabled. All other files has auto-growth settings disabled. That's why, for example, file 3, which is almost full and has auto-growth settings disabled, we can see that it's in a critical state because of free space issue. And right now, I want to simulate failure. To simulate failure against file 4. And I'm not going to write any data inside of this file, because actually I can do it easy way. It has an auto-growth settings enabled. Then it means that I can reduce amount of available free space at this mount point. Let's go to our SQL machine. And right now, I prepared some big files. Of course, for our case, 76 gigabytes is big enough. And I go to our mount point and copy this file here. Right now, and we can check that actually about no free space at this mounted volume. 245 kilobytes, actually nothing. And it means that right now, when I go back to the SCOM, I have to see that my database is in trouble because of file 4 suffer from free of leg space. Let's go and check how SCOM could be fast right now. OK. Let's go back to SCOM. Voila. It's fast enough. But let me show it to you again. So right now we can see that our database is in critical state. Our secondary file group is in critical state, and both files there are in critical state. And we can evaluate why actually it's happened. OK, we can see that the unit monitor for file 4 raised an error because we have no free space. Yeah, we crossed defined threshold for it. It was at 20%. Right now, I suppose there's actually less than 20%. And so right now, we can see that our database in critical state. And actually, it's time to do something. It's a time to save our database. And it's a good reason to find way how I can save my database at knowledge base. Actually, we've put some big effort to provide you very good knowledge bases which allow you to perform correct remedial action when you have some trouble with the database. So open a Health Explorer, open this monitor, and go to potential resolution. Come on. OK, maybe we can choose this way. It's very easy, yeah, right now, just to enable autogrow. I already have autogrow enabled for file 4, so maybe I can do it for other files. Wow, I have file 3 here, and it has autogrow settings disabled. And in fact, you can see that it's allocated on my very big C drive, which has a lot of free space. Let's go and try to save our database. Move to SQL machine. Let's open properties of my database. Go to files. Here we can see that file 4 has autogrow enabled, but file 3 has autogrow disabled. Let's enable it quickly without any additional settings. So right now, file 3 has autogrow enabled. And it means that whole disk, whole drive C, which has about 16 gigabytes available free space, this space all available for our data. Let's check. Maybe SCOM right now got it, and we can see that our database not in trouble anymore. OK. Another refresh. OK. And maybe we have no active alerts anymore. We still have it. Maybe it should work faster.
Yeah. We can go to them.
Yep. OK. Let's back to database state and check. OK. Let's see maybe some other monitor caused this problem. Go to Health Explorer and see that it's still the same issue. It still suffers from lack of free space. Okay. Maybe.
But it's back. It's healthy now.
Yeah.
It's healthy.
It's healthy. Yeah. Yeah, when you do demo with a SCOM, you should be very patient, you know. OK, so right now we can see that our remedial action, our very simple remedial action when we configure the autogrow settings for different file in our complex structure of database, so it succeeded, and right now we have this issue solved. OK, and so right now let's go to next scenario. OK. Just to summarize, which we seen just right now. So right now, we can allocate our files at mounted volumes. And the space monitoring will monitor these files, will monitor issues with such files correctly. We've implemented in the last version of the SQL Server Management Pack, which you can download from the Microsoft download. And right now, you can be sure that your files located at mounted volumes will be in safe. We also support different autogrow settings, and I hope that you will be happy with these our improvements. And right now, I want to talk to you about the next very important scenario which may cause your applications, which may cause your server's performance. Because you know that performance degradation, which may attack your application, or some deadlocks, mostly caused by some poor application design, yes, it's very painful, and which is more important, it's very hard to detect it, and detect it in time before it affects your business, and understand what's going on exactly. What blocking session is? It's a sequence of queries where one query blocks the next and go on and go on. And actually, length of this queue, length of this sequence, and the total lifetime of this sequence also could be very different. And it's very application and environment specific. And as I said, it may have very different reasons. So it could be some cancelled transactions. It could be some very long-running transactions which you have because of some application stuff or because of some environment things. It could be a lack of indexes at your database, which cause also very long transaction. Inappropriate locking hints and some other stuff, which, as I said, mostly caused by the poor application design. And right now, I'm going to show you how the SQL Server Management Pack work with blocking sessions. Okay. To demonstrate it, I prepared for you another database, which called blocking session DB. Very clear. And to remind you, blocking session issue is not on database level, yeah, because it's on the database engine level. That's why I'm going to open another subfolder here. It's a server roles folder. And so here the database engine state view. Here I can see all database engines in my environment. And I'm going to also try to make my demo at SQL O2 server. OK. So let's go to the SQL machine. And I prepared some fake transactions for you to simulate this problem. OK. It's transaction 1 and transaction 2. OK, great. You can see that this transaction, yes, it really makes some trouble because it opens transaction but doesn't commit it and doesn't roll back. Second transaction actually not better because it also opened transaction and tried to delete some records from the same table. Of course, if I try to execute it, oh gosh, wrong button. If I try to execute it, it looks like it's completed, but in fact we know the transaction is not committed. And so when I try to execute my second transaction, it could not be completed. So you can see that SQL Server continue executing query. And right now, if you experienced with a SQL Server, you know that I can review my blocking transactions directly in the SQL Server Management Studio. I can open reports and find here all blocking transaction reports which are available at SQL Server. And here I can see that no blocking transactions. Oh, it's mount point database. Sorry. Of course, we should check it for reports. OK. Blocking session DB. Yep. And so right now, the SQL Server show me that I have two blocked transactions. One of these transactions, which was executed first, called head blocker transaction, which actually calls all these chain. So right now we have a chain which has infinite life because there is no way to stop it. They fight for one resource, total deadlock. And let's look if SQL Server Management Pack detects this situation for us. Let's go to the SQL or to SQL machine. OK, and we can see that my DB engine is in critical state because of blocking session monitor. This monitor in the SQL Server Management Pack, it's disabled by default because not of all environments suffer from this issue. And if we just turn it on with default settings, it may cause some false alerts, which we actually try to avoid. And if you feel that your application may suffer from such kind of deadlocks or kind of pretty long transactions, you should evaluate how long this chain could be for your case. What is affordable and what is not. And what is the lifetime for this chain is affordable for your application and what is not. Because we can see that this monitor allows to configure these settings for you. I do some overrides for this monitor. So we have some overridable parameters here. And it's not about it. OK, maybe here. Wait, means.
Go to overrides.
Yeah, I think that it's in overrides it will be better. Use summary. OK, for all objects. Wow, I have no overrides. Great. Let's try to open it again. OK, so I overridden some intervals, some wait time for demo. It doesn't matter. OK, so actually, I have a better place where I can show you more details about this monitor. And this is resource which I really love to use. It's called MPWiki, where you can find documentation for all management packs available from Microsoft. And here we can see, for example, the health model of the SQL Server Management Pack. And I may go to the DB Engine class and to see what monitor available there. I can find there my DB Engine. Yeah, here. It's a blocking session monitor. And here I can evaluate what parameters available there. And I can see that there I can configure, I can customize number of blocked sessions. It's a length of my chain. And you can see the default value is only 1. And of course, if you have very loaded application, if you have some heavy transactions, and it's OK for you, you should increase this value. Second parameter is a wait time, which actually means like a lifetime of this chain, which also should be customized especially for your application and for your environment. These two parameters is the reason why we have this monitor disabled by default. And the first step which you have to apply is understand exact values which you have to configure for these parameters for each DB engine where I go into monitor this scenario. And only right after that, you should enable this monitor. OK. And let's go back to our demo scenario. And so you can see that right now we detect this failure. But you know that it's all about poor application design. In our case, it's about awful application design. And then we should perform it in 2 steps. What IT operations can do in this case? First, he can solve it very fast to unlock this transaction. And we will talk later about how to do it. But the second step, which needs to be done, is providing some detailed information to developers, to maintenance, who can care about indexes, who can care about maybe some hot fixes in your application or something else. And you have to provide information about what's going on there. And it will be not enough if you just say, hey guys, we had just some blocking sessions. And as you see, some report is available from the SQL Server. But here we have the SCORM, and we have the SQL Server Management Pack. It would be really great if we can take some information directly from this management pack. And fortunately, we can do it. OK, so let's go to Health Explorer again. Let's open this monitor and go to alert context. Wow, we have a lot of XML here. I can, as IT operations, I can copy. Yeah, my scroll is not so fast. Come on. We have a lot of diagnostic data here. And finally got it. OK. I can copy it, and then let's close all this stuff. Because right now, I can save it as an Excel XML file. And then I can open it. And then I can send it to developers. And they will have, actually, a lot of information. They have whole Maya chain. In my case, it's just 2 queries, and it's a simple. But they have transaction IDs. They have who is head blocker. They have SQL statement, which was the cause of the problem, and a lot of other information, which really help them to understand what's going on and how to resolve it. And you remember, when they work on it, definitely on production database, it should be everything OK. Because as IT operations, I couldn't be happy if this chain is still alive. I should kill it immediately. So any ideas how I can kill this chain? Guys, folks, have you ever tried to kill any transaction in the SQL Server? No? OK. I can kill it for you. OK, so let's go to SQL machine. And OK, let's open new query. And just to be sure, what is the close it? What is the number of transactions? OK, transaction 1 has ID 56, and it's exactly head blocker. It means that if I kill it, whole chain will be executed then, and so we have our resources unlocked. Yeah. So that's why I'm going to kill transaction 56. OK, it's very easy. I love Transact SQL because of this very clear, very clear language. Kill it. OK, command completed successfully. And so we can see that everything done. Transaction 2 also completed. Yes, we unlocked it, finally. And we can uncommitted. I can't believe. OK. Right now, we can go to blocking session database and check reports and to see if we still have blocking transaction or not. And SQL Server just said me that we have not any blocking transaction, and I'm pretty happy. Let's check if SCORM management pack also detect that our issue is resolved right now. OK, so let's go back to SCORM. May I close it? Yeah. OK. And let's try to find SCORM here. OK. Voila. Our SQL O2 DB engine is already alive, so I'm pretty happy. And so you remember that I killed this transaction, and then I send my Excel file to developers. It means that our issue solved in right now, in a short term, and I also initiate long-term solution, which will be applied by my developers, and I can be sure, I can hope, it depends on my developers, that this problem never appear in future. OK, that's all about blocking sessions. And let me go back to demo here. Yep. Yeah. Thank you.
So, all right. All right, thanks, Roman. That was exciting set of features we've added. That we also added capabilities to monitor database mirroring, because we know customers are going to use SQL Server, existing versions of SQL Server. So we added support for database mirroring monitoring in the SQL management pack as well. And this capabilities monitors not only the database mirrored state, but also the witness and the partner state as well. So since we are a little bit short on time, I'm just going to give you a quick diagram view of how that looks. So if I go to SCOM, if I go to the mirroring tab, we have a diagram mirroring view, which tells you very clearly which is your primary database and which is your witness and which is your secondary database. And we also created a custom view which kind of tells you visually where that secondary is and how the health rolls up into the monitor. So that's another great feature which is part of the SQL management pack for you to use along with always on as well. So kind of if you have a heterogeneous environment, you can use mirroring as well as always on. We've also resurrected the replication monitoring feature in SQL management pack. It was deprecated in the previous version, so we actually brought it back. It's a limited set of capabilities, not a complete replication monitoring, but it's still a basic set of features we've added for replication, and we're going to improve that over time. So let's move on to the last part of the demo, which is SQL Azure. So I did a session on Tuesday on System Center and SQL Azure on Azure, where I showed a detailed demo on SQL Azure Management Pack. How many of you attended the session? Okay, not a lot. So let me just quickly do what that scenario is. So we have capabilities. We know that a lot of customers are going to use SQL Server, but they also are looking at extending their application to SQL Azure at some point in time in future. And we want to make sure that you can still use your existing set of tools, such as SQL Server Management Studio, System Center, to really monitor the health of your SQL Azure database same way you monitor the health of your SQL Server on-prem assets. So for that, we've added some capabilities in SQL Server 2012 to make this hybrid experience much more easier for your database administrator as well as the IT operator. So the first thing we have added is backup and restore. So what we have done is from SQL Server Management Studio, you can actually back up your database, a logical backup, not a transactional backup, but logical point-in-time backup of your database into Azure storage, and you can restore that into SQL Azure. So let me give you a quick demo of how that is done. So I have a different machine here, which I use. So if you go to SQL Server Management Studio, you have this capability called Azure Storage. So you can actually connect to an Azure Storage account, which you have, and you can actually back up your data from your on-prem SQL Server into Azure Storage. Then you can use that Azure Storage to restore that into SQL Azure. So you can also use SQL Server Management Studio to connect to your database, but also to your SQL Azure database as well. So here in this view, I've connected to my on-prem, my Azure Storage account, and my SQL Azure. So let me show you how easy it is to back up the database. So I go to a database. In this case, I have a database called MMS demo. I go to tasks and have this feature called export data tier application. It opens up a wizard, and there's a new option called save to Windows Azure. Here I could connect to my Windows Azure account, which I've created. So I have a Windows Azure account called MMS2 demo, and I have the account key, which is the primary key which you get when you create the account in Windows Azure. So you just have to key in the primary key here, and once you connect, it'll pull up all the containers which I've created in that account for me. So in this case, I've created a container called demo container. And now what it's doing behind the scene, it's creating a backpack of the database and moving that backpack into the Azure storage. So if I go back to my view, and if I refresh this view, you see that it has created the backpack. Now I could go and use this backpack, and I can restore that backpack here. I can say, go to my Azure view, and these are my Azure databases, and I say import data to your application. It's going to pop up a similar wizard, but in this case, I can say connect to my Azure account, and it's going to show me the same backpack I did. And I just say next. And I can choose what edition of this database should it be. Should it be a web edition, which means I get a database size of 1 GB, or I can do a business application, which in this case I get a default size of 10 GB. So I'll choose business for this demo, and I say finish. So behind the scene, it's taking the same backpack and actually restoring it into SQL Azure. So once that is done, I should be able to go back to my SQL Azure account, which I've opened here. Right? This is my SQL Azure web portal, and if I refresh this, it's going to show me that there is a new database called business application. So if I go and collapse this, right there. So with few clicks, I was able to back up and restore the data. And take note, this is not a transactional backup. This is a point-in-time logical backup. But still, it's a simple disaster recovery story for your on-prem databases into Azure for your application. So once we have backed it up, we want to give a similar experience to IT operator to monitor the health of the same database. So what we have released is a preview of a public CDP preview of the SQL Azure Management Pack, which you can import. And once you import it, you can actually use System Center to monitor the health of that database. So let me go back to System Center. So once you import the SQL Azure Management Pack, you'll see a node called SQL Azure. And you can see the health of this database. And this is very similar. How do you discover this database? So we have created an authoring experience where you can add a monitoring wizard, and it will show a new option called SQL Azure. And once you go click here, you give a name. You select a default database, in this case, this. And here you have to give the logical server name which you get as part of your SQL Azure subscription. And you can create a run as account, which is simple authentication, which has your username, password, and you map that run as account to this logical server name, and that's it. Then the SQL Azure database gets discovered, and you'll see that information here. So for this demo, I'm not going to do that discovery. I've already done that. So once I go to this view, I see that I have a database, a logical server called VP GUID. And if I go to the database state view, I'll see that same database. And take note, my database, which I just created, the MMS demo, has already got discovered by the database, by SQL Management Pack. So very easily, the database which I created got discovered, and it's rolling up the health into the health model. So since we have a few minutes, I'm just going to hurry up on this set of views. So we have a bunch of perf counters, which we do, and we also have a set of monitors, which you can go against each of these databases, which you can configure. And we track a lot of things like availability of the server. Can I connect to the server? Can I query master? I also have performance views where I can monitor the free space, very similar to what you see in on-prem SQL Server. And I monitor a whole bunch of other counters like total CPU, total I/O, the network bandwidth. Whole bunch of counters are available for you to monitor. And you can set thresholds on that. And if you notice, most of these monitors are disabled by default to prevent noise, except for the free space monitoring, which is very similar to what we have for on-prem. So we've enabled the free space monitoring, and you can set thresholds on each of those monitors. So we hear a lot about hybrid monitoring. So with this SQL Management Pack and the SQL Server Management Pack, you can use the power of SCOM to create these dashboards, which I've done here. So this is a dashboard which has two views. What you see on the right side is the SQL Azure database view, and what you see on the left side is your on-prem view. So in very, very simple dashboard, where you can really look at your hybrid application in one simple view. And at the bottom of the view, I've created a dashboard which is showing all the perf counters for free space for both on-prem and for SQL Azure. So with these two management packs, you can really get a hybrid monitoring experience for your IT operators. You could also create interesting diagram views, which is showing your SQL Azure database health on the right side, on the left side, and SQL Server database health on the right side. So that is truly a hybrid experience, which no other vendor out there offers except Microsoft. And really, we're bringing the IT operators' journey to the cloud much more seamless and easier by leveraging the existing tools which you already know and love. So to conclude our presentation here, let me go back to the deck. So as I said, that we have the public CTP available. The public CTP only supports SCORM 2007 R2 because we had a bug in SCORM 2012 which was preventing support for that. But we've already fixed the bug. The demo I showed you was on SCORM 2012. So we're going to once we finish testing of that fix, we're going to update the current download to support SCORM 2012. But the current download only supports SCORM 2007 R2. So those are the different counters we track. So conclude, we did a lot of things. We actually went through a whole bunch of demos today. We covered a lot of things, but essentially the key takeaways is with SQL Server 2012, with always-on capability, what you're really buying is peace of mind. Really, with always-on capability, you can really use SQL Server 2012 to monitor your Tier 1 application and use SQL Management Pack to get that experience in SCORM. And with SQL's Azure Management Pack, we make the transition from on-prem to cloud much more seamless and much more easier. And we really value your feedback. So with that, there are other sessions which are related to this. The first one is my session on which I go into this demo much more detailed way. And the second one is our private cloud appliance, which you see in the server aquarium, which uses most of the management pack experience which I showed you, but in an appliance. So with that, thank you for coming, and we are open for any questions you have regarding this. So any questions on SQL Management Pack or SQL Azure Management Pack? Yeah, go ahead. So the question is, what we just showed, is the management pack available? The answer is yes. SQL Server 2012 management pack was available the same day SQL Server 2012 was available. So SQL Server 2012 management pack is available. SQL Azure management pack is also available. We released it last month, but it's a public CTP, and that supports SCORM 2007 R2, as I said, and we're going to update that very soon to support SCORM 2012. Yeah, so the question is, are these two separate management packs? The answer is yes. So, yeah, if you go and say, just search for, if you Bing SQL Server Management Pack, the one you see in the site is the most current version of the management pack. And that supports SQL 2012, SQL 2008, and 2008 R2, and 2005. So everything is packaged into one management pack. But when you download the MSI, you'll see an MP file called SQL Server 2012, which you have to import. Any other questions? Yeah.
Yeah, the SQL Management Pack had given an example that database engine. That's the same thing as an instance.
Yes. The question is, yeah. Why did we call it database engine?
Yeah. Why don't you call it an instance? So
So the question is, why are we calling it database engine as opposed to instance? So this is some history behind this, and the people who are building the management pack before were from the core SQL engine team, and they said, let's have a view where we call it database engine. So I really don't know why we called it, but that's something we can easily fix. It's just a view for consistency's sake. That's good feedback. We'll incorporate that.
Oh, mostly it's to underline the separate server role which we have there, that we may have some analysis server, some reporting there, and here we have DB engine role. It's about role, not only about instance. Yeah. But yes, thank you for feedback. We prefer to have the most clear user experience in our management pack.
All right. Thanks again for coming. Your feedback is important, as I've always said. Keep that coming, and thanks a lot.